Okay, let's dive right into this. Imagine you're a parent, right? You've just taken your kid to the clinic for a routine vaccination. You did your research, you held their hand through the inevitable pinch, and now you're heading home just hoping for a nice, quiet evening. You're feeling pretty great about protecting them. But as the afternoon wears on, the script kind of flips.
A few hours later, reality sets in. A fever spikes. Your previously happy child is suddenly incredibly cranky. Their arm is red, it's sore to the touch, and they are flat out refusing dinner. It's a super relatable moment of panic for any parent. And well, what's the first thing we do? We grab our phones. Within minutes of scrolling, you are bombarded with stories claiming these exact symptoms prove something has gone terribly wrong. Suddenly, normal parental anxiety is instantly weaponized into deep fear.
But I think we need to pause here and ask a really fundamental question. What if these symptoms are actually evidence it's working? I know, that sounds like a total paradox. We are so conditioned to view a fever or fatigue as a sign of sickness, a sign that the body is failing in some way. But what if those very symptoms are undeniable physical proof that the vaccine is doing exactly what it was designed to do? To understand why, we have to look closely at how vaccines actually interact with our biology.
To get there, we first need to dismantle what I like to call the pure liquid myth. So many of us, honestly without even realizing it, imagine a vaccine as this perfectly pure, magical liquid that just quietly enters the body, magically creates immunity in the background, and then vanishes without a trace, leaving us completely undisturbed. But in reality, that's just not how vaccines work. Biology is messy and it's highly active. If a vaccine just entered the body and did absolutely nothing to stir the pot, your immune system wouldn't even know it was there. So what is actually in that syringe? Well, the foundational ingredient is the antigen. Think of the antigen as the teacher. It's what trains your immune system to recognize a particular disease, whether that's measles, pertussis, the flu, whatever it might be. When the antigen enters your body, your immune system acts like a highly dedicated student. It studies that antigen, analyzes its structure, and begins building immune memory. And the entire purpose of this process is preparation. It allows your body to respond much faster and with overwhelming force if it ever encounters the real dangerous infection out in the wild. That is the fundamental goal of vaccination.
But here's a really crucial secret of modern medicine. A vaccine isn't just an antigen. If you just injected an antigen all by itself, the immune system might actually just ignore it altogether. That's exactly why vaccines include things called adjuvants. Adjuvants act as an alarm, alerting the immune system that something important deserves immediate attention. They aren't in there by accident. They are a highly calculated part of the vaccine's design to preserve effectiveness and ensure your body responds efficiently.
This all builds into a fascinating, microscopic journey, basically happening in 4 clear steps. Step 1, the injection happens. Step 2, the adjuvant goes to work. Think of the adjuvant like flipping on a massive spotlight in a pitch-black room. It literally screams, "Hey, look over here!" Step 3. Instead of quietly ignoring the vaccine, your immune system sees that glaring spotlight and immediately dispatches specialized immune cells right to the injection site to investigate the scene. And finally, Step 4, those cells encounter the antigen and immune memory is successfully built. So the vaccine isn't sneaking in, it's intentionally sounding an alarm. Now comes the part almost nobody talks about, and it's highlighted perfectly by what our source material notes. Modern vaccines are specifically designed to encourage immune cells to gather at the injection site. Now, I know that sounds entirely backward to how we normally think about medical progress. You'd naturally assume that newer, more modern vaccines should cause fewer reactions, right? Well, not necessarily. Because we now know that drawing immune cells to the site is exactly how you build robust immunity. Some modern vaccines are intentionally designed to be more reactogenic. They are literally designed to create that local immune response.
Because of that deliberate design, we see a very specific list of expected reactions. A sore arm, redness, mild swelling, a low-grade fever, fatigue, less appetite, maybe a child just wants to sleep way more than usual. Healthcare providers entirely expect to see these. Most of those local reactions, where the area feels warm, maybe becomes firm, or stays slightly swollen for several days, they occur exactly where the vaccine was injected, right where that adjuvant spotlight was turned on and all those immune cells gathered to do their heavy lifting. It can certainly worry parents for sure, but it is completely 100% normal. So the absolutely crucial point here is how we reframe these symptoms. A little redness or a warm arm isn't always a sign that something went horribly wrong. Actually, it means your immune system is actively doing its job. These symptoms, while absolutely unpleasant and really hard to watch in a little one, are actually a biological success story. They indicate that the immune system has successfully recognized the vaccine, hasn't ignored it, and is responding exactly as appropriately as we want it to.
But this leads us to a massive myth that causes just as much anxiety on the flip side. Does no fever mean the vaccine didn't work? Think about it. If symptoms mean the immune system is working, then naturally people assume a total lack of symptoms must mean a total lack of immunity. Parents get super anxious when the thermometer spikes, but surprisingly, they also get anxious when it stays completely flat. They worry that if their child didn't react, the vaccine was just a dud. This idea that symptoms act like some kind of scorecard for your immunity is widespread, but it's fundamentally incorrect.
And here is exactly why. Every single immune system is different. Some vaccines produce noticeable reactions, while others produce almost none at all. Some people develop a sore arm, while others barely even notice the injection happened. A fever is just one possible normal inflammatory response. It is absolutely not a measurement of how much protection you developed. Experiencing a fever doesn't mean you developed stronger protection than someone who didn't. And producing zero symptoms, that is also completely normal and successful. The immune system is incredibly complex, and neither response means the vaccine worked better or worse.
So, if a fever does occur, how should we handle it? Well, the goal isn't to let a fever run to somehow prove the strength of the immune response. That's just another big misconception. Managing symptoms is actually pretty straightforward. You comfort the child, encourage fluids, and use age-appropriate fever reducers when recommended by a healthcare provider. You see, a mild fever after vaccination simply reflects activation, not an infection. You aren't hurting the vaccine's effectiveness by giving a little fever reducer. You're just helping the child feel comfortable while their body quietly finishes building that crucial protection in the background.
And this perfectly illustrates the most vital concept in this entire explainer, the massive difference between a reaction and a complication. Because your immune system is responding, your body temporarily reacts. Confusion between these two words is honestly where so much fear originates. People use them as if they mean the exact same thing, but they really don't. A vaccine reaction, like the fever, the redness, the crankiness we just discussed, that's an expected response. It's part of the biological plan. A complication, on the other hand, is an unexpected medical event. Those are two completely different universes in medicine.
Which leads us with a critical pivot. We've spent this explainer exploring why normal, expected reactions are actually good news. They're proof of your immune system shining a spotlight and doing its job. But if reactions are expected and normal, what exactly is a vaccine complication? What does an unexpected medical event actually look like, and how rare is it? Understanding that difference totally changes how we view vaccine safety altogether. But to fully grasp the reality of complications, we'll have to keep digging into the science. Thanks for joining me on this explainer, and keep asking the right questions.